Sphere Network, and in this video I'm going to show you how to iterate through a 2D array by only doing it with one for loop. So this will actually make things a little bit easier for you when you're doing a 2D array. Maybe you're doing some kind of 2D game and you need to iterate through the tiles that are on the ground and the screen or something like that. Typically, you'll see newer coders that will use 2 for loops to get this done, but it can be done in 1 for loop, and that's what I'm going to show you today. So the first thing you need to do is you need to make a new project. So I've gone ahead and made a project 2, and then I copied the code from the last project into a new file called main.cpp in project 2. So that's the starting point. I'm going to keep the prompt function because we want to still have the prompt happen. But now after the prompt returns successfully, we want to do stuff. So let's talk about the 2D array. So as you can see here, I've kind of drawn out a 2D array and what it looks like. And this array is 4 by 4. So it has 4 rows and it has 4 columns. And typically you'll see someone iterate through this array by creating a for loop. And then they'll create an indexing variable. Let's call this I. And then they will go I less than 4, I plus plus. And they'll create the first for loop. And then they'll create a second for loop, like so. And they'll add j. So j is less than 4, j plus plus. So if you're not familiar with what a for loop does, it basically iterates given the starting and ending conditions. So we're going to start j at 0. And while j is less than 4, we're going to continue to increment j, and we're going to do whatever is in here. So we do the for loop stuff for j inside that one, and we do the for loop stuff inside I for that one. And this is just 2 separate for loops. But if we want to iterate through this entire thing, we need to know the row and the column of each cell. And so what they'll do is they'll take the end of this loop and they'll place it here. And so now we have a nested for loop. We have j, which starts out going from 0 to 4, and then we have I, which goes from 0 to 4. And so if we came down here inside this middle function and we said let's see out the values for j and I. So let's say j and I, and this is going to be equal to j. Add an equal sign real quick, make it easier. Say j and I. And then we'll end the line, right? So this is the standard way that people would do it. Let's compile it, and then let's run it. And as you can see, when I run the program, it starts out with j equals 0, and then it goes to the next part where I equals 0. And so the first term is j, for j and I is 0, 0. And then, since this condition still holds, by the time we print out the first version, we get here. And I is 0, and since I is less than 4, then it increments to 1. And so now we go through this loop again, but now j is 0 and I is 1. And if we look at the output, sure enough, that's the result we get. 0 for j and I is 1. So this process will continue, and we'll iterate through all of the cells in the 2D array, and we'll actually be able to get their values. You can see that j represents the row of the cell, and I represents the column of the cell with this output. So that's the beginning. That's the starting point so far. Okay. So now let's try to unwind this, and let's try to create this with one for loop. So looking at our grid here, we know that we have a 4 by 4 array. Before we start, we know that that's what we're working with. We also know that there are 16 cells in a 4 by 4. So using that knowledge, we're going to create a new for loop. And we're going to create a new indexing variable, and we're going to call it k. And while k is less than 16, we're going to increment k. So this is where this is going to work. Okay. So we have our old for loop up here, and we're going to make our new for loop. So I'm actually going to go ahead and comment this out so that we don't run this code, but we still can look at it. Okay. So we're walking through 1 through 16, but in C++ language, we start at 0. So really this would be something like, get a new color out here. This would be 0. This would be 1, 2, 3, and then it would continue from there with this one being 4, 5, 6, 7. So in C++, the indexing starts at 0, not at 1. So we'll have to incorporate that into the calculations, and that's why we start at 0 here. And so the first thing we need to do, we have the index of the cell in a 1D array. I'll show you that here. So before we were using I and j. So I'll just give you sort of an axis here, like this, and like this. And before we had, let's see, J was our row, and I was our column. But now we want to have only one variable that we're iterating through, one for loop. So we're just going to have k, which is the index. So we're going to start with just the index of the cell and then calculate what the row and the column is. And so we can do that by creating some new variables here. Let's create j, and then we'll just set j equal to 0 for now. And then we'll also create I. Now, if we want to get j, then we need to take k and we need to divide by 4. And we'll see why this works in a moment. So if I take any of the values, remember that k starts at 0. So this goes 0 to 15. So let's say I take this value here. This value is 3 in programming language because it's 0 to 15, so we have to minus 1. So this would be 3. And when I divide 3 by 4, I get 0.75. But because j can only be an integer, it is rounded, and it will be rounded down. So this will become 0. 3 divided by 4 is 0 when you're looking at the integer space. Now, if k was 5, and 5 divided by 4 would be 1 then. We look at the graph here. So 0, 1, 2, 3, 4, 5. 5 is this position here in this C++. Remember, 0 to 15. So if we're at position 5 here, then our row should be 1 and our column should be 1. And so if we take 5 divided by 4, that's 1.25. But because we're only allowing integers to be the result, we have to round that, and that becomes 1. So our rows work correctly. And actually, we don't need to call this j. Let's call this row. And then we'll call this column 2. So to get the column of the 2D array, or the cell we're working with, we take k and we take it by the modulus of 4. You've probably never seen the modulus command before. It looks like a percentage sign. So what does the modulus command do? So if I take 3 modulus 4, I get 3. And basically what this is modulus returns the remainder of a division. So if I had something like 7 divided by, or 7 modulus 4, what would that be equal to? That would also be equal to 3. Because 7 divided by 4 is 1 and 3/4. Make this maybe, but yeah, 7 modulus 4 is equal to 3 because 7 divided by 4 is equal to 1 plus 3/4. Move this over a little bit so you can see. So basically what's happening is that the modulus command returns the remainder of the division. So you take the number and you divide it by the number that you want to modulus it by, and then you get rid of the quotient and only look at the remainder term. And that's how you actually calculate what the column is. So for instance, if I put in 3 modulus 4 is going to be 3, and 0, 1, 2, 3 would be right here. So cell 3 is at row 0, column 3. Okay, so now, instead of looping through something twice with 2 for loops, we're only using 1 for loop. And you may ask yourself, why go through all this trouble to only have 1 for loop? And the main reason for that is speed, basically. When you're programming and you're doing a double for loop, you'll have a lot of people that will actually put the bulk of their code here. So I actually just can't write gibberish, but I'll put comments. So let's say that they have a bunch of code, and it's all within this second for loop that goes over I. Well, all the code that's in here has to be run j, the maximum of j times the maximum of I, because we're going through a loop twice. So we actually have to take those two bounds and times them together, and that's how many times we're going to be printing out the cout statement. So if I have 4, j goes from 0 to 3 basically, because it has to be less than 4, and I goes from 0 to 3 because it's got to be less than 4. So it has 4 steps, I should say. It goes 0, 1, 2, 3, and so j does the same. So we take 4 times 4, and we should get 16. So when I print this out, I have 16 results. And so if you're a new coder and you come in here and you're doing lots of calculations like the cosine squared plus the sine squared of some random function, and then you take that all and you square root it, let's say. Square root is a very slow function in programming. And you're doing all these calculations, well, you're going to have to do it 16 times, and it's going to be very inefficient. And so what you want to do is you want to try to take as much of this code out of this loop, and if you can, you want to put it up here so that it's only calculated once for each j value. It's not calculated every single time. And if you really work on your optimizations, maybe some of these variables can be pulled out before we even start the loop, right? And so then it's only calculated once. It's not calculated 16 times or n squared or whatever. And so that's the big difference here is you want to set up a single for loop when you can, and you want to try to take all the information that you're calculating inside the for loop and you want to pull it outside so that you're not calculating the same variables over and over and over when you only need to calculate it once. So let's just get a simple example about that. So let's say we want to get some values for this 2D array. Let's say we want to put some points down. So okay, so let's say we have a float x, which is some value, and we have a float y, which is some value. And we want to have some kind of spacing. So let's say our float spacing is 10. All right. So we want to iterate through these cells, and we want to put them in a 2D array, but we want to space them out a certain distance from each other, and we want it centered on the 0. Because if I did something like this where I said, okay, well, the x value is just going to be the spacing times the column, or if I did the spacing times the row here, that would be fine, but it wouldn't be centered on 0 because the first value would be 0, 0, and so x and y would be 0, 0. So we actually have to offset this by a certain value. So we actually need to offset this by half the amount that's in the row. So since we have 4 in the row, we need to divide by 2 and times that by the spacing. So 4 divided by 2 is 2, so 2 times spacing. We actually need this value negative, and you'll see why in a minute. So if column is 0 as we start, then this will be 0 and we'll be at negative 2 spacing. If column goes up to 3, which is its maximum value, then you will have 3 times spacing. Oh no, okay, whoopsie. This should not be 4 divided by 2. My bad. This should be the number on the side minus 1 divided by 2. That's how you get the proper spacing. Okay, so 4 minus 1 divided by 2 is 3/2. Right? So then, yeah, that's correct. Because when column reaches its maximum value, which is 3, we'll have 3 times spacing. And this is negative 3. You can look at this as negative 3 times spacing. Some brackets here, divided by 2. So we're offsetting the x-axis by half of the width. The width is 3 spacing, because it's spacing times the maximum column value. And we want to divide by 2 so we can offset it, so that when we enter 0, we're at negative 3 spacing over 2. And when we enter the maximum value 3, we're at 3 spacing over 2, a positive value. And so that all works out correctly. So we're going to do the same thing here. For the y value, we're going to go, it's 4 minus 1, so 3 times spacing divided by 2 plus spacing times row. Now, let's go ahead and see out these values and make sure that we have them correct. What we should see is we should start in the negatives and we should move to the positives. Okay? So we're going to do that. And as you can see, we only have one for loop. We're not using 2 for loops. I'm getting all sloppy with that. So let's run this. Okay, and you can see the first value is at negative 15, negative 15. And we're using a spacing of 10, so the next step should be 10 further on the x-axis, and it is. It's negative 5. The y hasn't changed yet because we're still on that same row. And then we go 5, negative 15, 15, negative 15, and it continues until we get to the positives, where we're at 15 and 15. So you can see right now, with just this simple code here, I've actually created a 2D array of vertices that are spaced 10 apart, just using this little bit of code here. And so now we can actually do a little bit of optimization here, and this is why you do the single for loop. So you can see here that every time we come into K, for every cell that we look at, we have to calculate what is the row and column of the cell. And then we have to define what the spacing is. And then we have to calculate the x and y value. Well, for one thing, we don't need the spacing to be defined every cell. We can define that before the for loop starts, so that saves us a little bit of time. And then this value here is constant. This value never changes because the spacing is constant. So we don't need to calculate this value every time. So we're going to call this offset, or we'll call this, we'll just call it off x. And then float off y equals off x, because they're identical. It's a 4 by 4. Okay, and so then we'll just add those variables down here, off x and off y. So now when we run through our for loop, we are not defining the spacing every cell. We're not calculating the offset every cell. We're doing that all before we even get into the loop. And so this is sort of the basics of doing a little bit of optimization in your code. Is you want to look for spots where you're calculating something multiple times, but you don't need to calculate it multiple times. You only need to calculate it once. And so that's what we're doing here. And so we have this. So we can go ahead and get rid of this double for loop. We never needed that to begin with. And so now we just have our basic 2D array. And it's optimized so that we are not doing repetitive calculations, which is good. And this will be the starting point of the next video that I will be doing, which will be coming out in about a week and a half, 2 weeks time from now. So go ahead and stay tuned for that. If you have any comments or any questions, or you want to see something explained in coding that you don't really understand, then go ahead and drop me a comment.